Right. Then we'll start the discussion. Okay. Right. Question number 1. A projectile question. Particle is projected from a point O, which is at a height h above the ground, with the angle of elevation alpha. The particle falls on the ground at a horizontal distance 2h from the point of projection. Find the velocity of projection in terms of g alpha and h. Right. Question number 1. Part A. Here O. Point O is here. Projected this way. Suppose the velocity of projection u with an angle of elevation. Angle of elevation means with the horizontal, the angle above the horizontal. This, right? That's the angle of elevation. This is h. This way, particle moves and comes to ground here. Okay. The distance is given as 2h. Yes, and up time t, the angle of elevation of the particle from O is theta. After a time t, the angle of elevation, right? Angle of elevation means always with the horizontal, the angle making above the horizontal level, no? Right. From O is theta, and its direction of motion makes an angle gamma with the horizontal. No? Of time t here, suppose then particle is moving along the direction of the tangent drawn to this point R. Right. So then here I'll take vertical displacement at time t is y. This is y. Okay. And this is x. Right. Angle of elevation at time t mean this O and this point. This point and this point we join this way. This is theta. Right. This angle is alpha. Okay. Here at this moment, I'll take the horizontal velocity component as W, vertical velocity component as V. Right. I'll take this point as Q. This is at T equals T. Okay. I'll take this point as P. This point is P point. Yes, at this point, once the particle comes to this ground, at this point, it has horizontal velocity component. That should be the initial horizontal velocity component u cos alpha, no? We said what? During the projectile motion, horizontal velocity component does not change u cos alpha. Okay. I'll take the vertical velocity component as v dash. V dash, huh? Right. Right. So then we apply equation of motion. This angle given as gamma. This angle given as gamma. That means this is the direction of motion at the point Q. Particle moves along the direction of the tangent. When the particle passes the point Q, particle has the horizontal velocity W. W is really u cos alpha. V, vertical velocity component, the angle between them is 90. Then really we can write tan gamma. Tan gamma is equal to V over W, right? Tan theta is equal to Y over X. Okay, right. And the one given, no? As the particle hits the ground, if the direction of motion makes an angle beta with the horizontal when it hits the ground, right? So this is the direction of motion at that moment. Okay? When we construct a tangent at this moment, okay, just like this, no? Right? This is the direction of motion. When we construct a tangent, the graph, this is beta. Then tan beta is u cos alpha over v dash. Okay, no? Yes. Now we can write for OP motion, we can apply S equals ut, rightward. Then horizontal displacement is 2h, 2h u cos alpha times t. T you can subject here, 2h over u cos alpha. Okay. Now same whole OP motion we apply S equals ut plus half at squared vertical upward or to P motion. Then for motion from here to here, we apply S equals ut plus half at squared upwards. Initially here, finally particle is below this level, right? Then it has moved downwards, displacement h, but we apply this equation of motion upwards. So therefore that h should be minus h. U should be u sine alpha. T is this time 2h over u cos alpha. A is negative, g. T squared is 4h squared over u squared cos squared alpha. Here you can cancel down this. Yes. Now by this you can subject u squared here. This 2 and this you can cancel down. 1h we can cancel down here. Bring this term to this side. Then we get 2gh 2gh upon u squared cos squared alpha. Take that to the side. Here 2 tan alpha. Take this minus 1 to right hand side plus 1. Then bring this way here, u squared here. Then we get u squared 2GH. U square comes here, this comes here. Cos squared alpha. Two tan alpha plus 1. Right. Ask you to find a U. Cos squared alpha root means 1 over cos alpha. This way. 2GH over 2 tan alpha plus 1. Right. Here we get 5 marks. Apply this equation of function, another 5 marks. Getting this answer for you, we get 10 marks. Okay. If after time t, the angle of elevation of the particle from O is theta, and its direction of motion makes an angle gamma with the horizontal, show that this also. Right. Now we apply for OQ motion. Okay. For OQ motion, for O to Q motion, we apply S equals UT rightward. Right. When the particle moves from O to Q, horizontally it moves X, S is X, U cos alpha times T. Okay, number 1. For the same motion, we apply S equals UT plus half AT squared upwards. It is Y. U sin alpha T minus half GT squared. Number 2. Right. Right. And the same motion, we can apply V equals UT. V equals U plus AT upwards. I took the velocity as V, initial velocity is U sin alpha minus GT. This is number 3. Right. And this W equals U cos alpha. W equals U cos alpha. Number 4. Right. 5 mark for each. Right. Then we can take, this is number 1 now. 5 marks. We know y of x is tan theta, no? Divide 2 by 2, we divide by 1. Y divided by x. U sin alpha t minus half dt squared. X is U cos alpha t. Here, t and this t you can cancel down. Y of x, here what? Y of x means tan theta. This is tan theta. Y of x tan theta. Okay. Now divide this by this. You get tan alpha minus gt divided by 2 U cos alpha. Okay. And just take this step. Number 5. And next one is here tan gamma. We can write V divided by W. Tan gamma. Also tan gamma. V upon W. V is u sine alpha minus gt w u cos alpha. Again, you can simplify here. Tan gamma divided this and this, you get tan alpha minus gt divided by u cos alpha. Right. Okay. For this equation, 5 marks come in. Correct, no? And now we can take the next answer. Right. Here, subject this and put that way here. Take this et over u cos alpha. Tan alpha minus tan gamma. Put that pair. Put in 5. Five is here. Tan theta is equal to tan alpha minus this 2 I can write as half. That dt over u cos alpha means tan alpha minus tan gamma. Tan alpha minus tan gamma. Then simplify this. For this we get 5 marks. Right, tan gamma for this 5 marks coming. Now simplify this, multiply by 2. You get 2 tan theta. Tan alpha plus tan gamma. I don't know. For the last 5 marks. Okay, now to get the next answer, for this OP motion, we apply V equals U plus AT. Downwards for OP motion, we apply V equals U plus AT downward. V means final velocity. When the particle comes to the ground at P, it's V dash. V dash. U mean initial velocity. Initially, U sine alpha. It is to upwards minus U sine alpha. Plus G times T. Okay. But this T is the total time particle takes to move from O to P. That time here we found 2h over U cos alpha, no? T is 2h over U cos alpha. V dash minus U sine alpha G 2h over U cos alpha. Right, for this 5 marks. Right. But here tan beta is what? V dash over U cos alpha, no? But tan beta is V dash over U cos alpha. V dash over U cos alpha. Yes. Now put that there. Tan beta V dash this answer, 2gh over u cos alpha minus u sin alpha divided by u cos alpha. Okay. Then we'll simplify this. Tan beta is divided by this means 2gh u squared cos squared alpha minus divide this by this, we get tan alpha. Correct, no? So this u squared we cannot substitute. Right, we got an answer for u squared, no? Here, this part. Okay. We need there 2gh upon u squared cos squared alpha. That means I bring this part where here, then we get 2gh divided by u squared cos squared alpha. I bring this where here, 2 tan alpha plus 1. Then we get 2gh over u squared cos squared alpha is 2 tan alpha plus 1. 2gh over u squared cos squared alpha. This is right, 2 tan alpha plus 1, no? 2 tan alpha plus 1, this part, minus tan alpha. Then we get tan beta is equal to tan alpha plus 1, right? We get 5 marks for this. This is 5 marks on that part A. Okay. Next part is the friction part. Friction question. Okay. Yes, it says uniform solid sphere where W rest on a rough plane inclined at an angle alpha. Right. Right. Okay. Yes, when the string AB is horizontal, the sphere is in limited equilibrium. Show that the angle of friction is alpha by 2 and find the tension in the string. Yeah. Limited equilibrium mean what? You know, when the object is ready to slip, suppose the object is ready to move this direction, that moment only we define as the limited equilibrium. That occasion we know the frictional force is frictional limited frictional force. In this case, the normal reaction, if I go like this, right? You know, at the limited equilibrium moment, the resultant of normal reaction and frictional force we can mark like this, right? Now object is in limited equilibrium, that means ready to move. That instant, the resultant of frictional force and normal reaction, that is this, it makes an angle with the normal reaction, this angle only we define as lambda angle of friction. Understood? Right. Now I can draw it like this. This is the plane. This is angle alpha. This is the sphere. This is the sphere. Then to the highest point, the string is joined. This way, tension acts in the string. Tension T this way acts. Okay. And weight W acts like this. Weight W is a uniform sphere, no? Acts through the center of gravity of a uniform sphere. Center of gravity is at the geometric center. Then you know here, this way it passes through the highest point of the sphere where the line of action of W produced. And the two more forces acts now. That is the normal reaction here, right? It passes through the center of the sphere this way, R, and limiting frictional force is this. If they are 90 now. Yes. Now I can find the resultant force for the frictional force and normal reaction. The resultant of frictional force and normal reaction. The frictional force resultant of frictional force and normal reaction, if I take, they together give one force. The resultant of frictional force and R, I take, then they together give one force. Other force is W. Other force is tension T. Then finally, there are three forces acting on the sphere for its equilibrium. The result of these two, one force, W, T. You know, when any object is in equilibrium under the action of three forces, they must meet at the point. Yes. Then this W and T already they meet here. Then the result of these two should also be passed to the point. This. Understand? Okay. This way, right? You know, according to our definition, what? This is the lambda. This is lambda. Right? This is the angle of friction. Now let us find this angle. That can easily be found. But you know, when we produce this line of action of weight W, here 90, this is 90 minus alpha, this is 90 minus alpha. Since here we have 90, this angle is alpha. This angle is alpha. Okay. If you take this as lambda, the angle of friction, since this side radius is equal to this size, this side, the radius, is also lambda, angle of friction. So then lambda plus lambda is equal to alpha. By the diagram, lambda plus lambda is equal to alpha. Lambda equals alpha by 2. So therefore, we get angle of friction is alpha by 2. The diagram 5 marks. Taking this as 5 marks. Right. In this case, you must write this in words. Therefore, angle of friction is alpha by 2. For that, you get another 5 marks. Write down in sentence. Therefore, angle of friction is alpha by 2. Angle of friction is alpha by 2. For that, another 5 marks come in now. For that statement, another 5 marks. Right. Right. So then I'll take this point as x. Then to find the tension T, I'm supposed to take moment around x. T gives clockwise moment, W gives anti-clockwise moment. Okay. I will take the radius as simple A. Then, yes. By T, we can take the moment, right? Right. So when I take moment around x, I have to make this construction. From here, I must draw perpendicular line. Since this T is horizontal, the perpendicular to this T should be vertical. Therefore, this red line is vertical. It is the required perpendicular distance to take moment of T around x, right? You can very clearly see if I draw a horizontal line here, this way, this length is equal to this length from here to here. Okay. Then you can take that length out. Here, this is radius. I take radius as A. And this part next. Right. This also from here to here. Again, radius A. This is alpha. Right. Therefore, this is A cos alpha. Okay. A cos alpha. Right. Then the required length is A plus A cos alpha. Then moment of T around x, T times A plus A cos alpha equals, yeah, this W I resolve here. Then one component we get W cos alpha that passes to the point x, no moment. W sin alpha is acting this way, giving anti-clockwise moment. So this W sin alpha acting this way, no. The required perpendicular distance going to be radius A. W sin alpha into A. W sin alpha into A. A. You can cancel now. Then we get T equals W sin alpha over 1 plus cos alpha. Right. For these 5 marks, for these 5 marks, for these 5 marks. That's how we take that answer. Right. Okay, now question number 2. Question number 2. Okay, two spheres AB with same radii and each of mass m is moving in opposite directions with velocities 4 and 8 meters per second respectively. If they collide directly and the coefficient of restoration is E, then find the velocities of them after the collision. One half of the initial kinetic energy is lost due to collision, so that E to third. Right. Right. This way. Question number 2. Part, right. A here, B here. After collision, I draw like this. AB, MM, this way 4, this way 8. A, B, M, and M, V1, V2. I can apply conservation of linear momentum rightward after momentum, after impact, MV1, MV2 total momentum, M into 4 M minus 8M. M you can cancel down. V1 plus V2 is equal to minus 4. Number 1, 5 marks. We apply Newton's law of restitution this way. What is that? E times velocity of approach. What's that? Velocity of approach is 12, no? Right. 12 equals velocity of separation. V2 minus V1. Number 2. Also 5. So at 1 and 2, then we get V2. I'm not going to show the steps in simplification, that's simple thing. V2 2 times 3 minus 1, 5 marks. 1 minus 2 gives second answer. 1 minus 2. It gives V1 minus 2 times 1 plus 3E. V1 negative means it reversed. 5. Okay. Now, given this way, 1/2 of the initial kinetic energy is lost. 1/2 means what? 1/2 means half of the initial kinetic energy lost. That means after impact, the kinetic energy available in the system is exactly half of the initial one. Then I can write kinetic energy retained in the system after the impact. What is the kinetic energy retained in the system? Half m v1 squared, half m v2 squared. This is the after impact, the available kinetic energy in the system. This is really what? Half of the initial one. It is equal to half of the initial kinetic energy. Initial kinetic energy is half m4 squared, half m8 squared, like this. Then, right, we can cancel down this half. Right. Write in this 5 marks. Write in this 5 marks. M also we can cancel down. Okay. Then here we get V1 squared plus V2 squared is equal to here 8, here 32, 40. Then substitute for V1 squared. What is V1? This minus 2, 1 plus 3e square this. V2 squared 2 times 3e minus 1 perfect square 40. Okay. Yes, when you simplify this, we get, simplify this. I'm not going to explain simplification there. E squared comes as 8 over 18, that means 4 over 9. Simplify, yeah. Take the square root. This is 4 over 9. E is a positive value. Take the positive square root. E is 2/3 for this 5 marks. Totally for this question coming 35 marks. Huh? Number 2, part B. Work power energy question. Trailer of mass 750 kilogram is pulled up on a road with an inclination 10:1. What is meant by 10:1? 10:1 means what? All right, climbing along this hill. No? When along this hill moves 10 units from the initial level, it rises 1 unit. That's the meaning of 10:1. In other words, if this angle is theta, sine theta equals 1/10. That's what it says. Sine theta equals 1/10. Yes. Sine theta is 1/10. Okay. 750 kilogram, 1000 truck. Truck and the trailer have been joined by, right? Of the engine of the truck is 45 kilowatt. All right. You see, tractive force available. H is 45 kilowatt. Okay. This is 1000. This is 750 kilograms. Sine theta equals 1/10. Okay. The system is moving with an acceleration 1 meters per second. The resistance against to the motion is proportional to the mass. And if the system moves with the velocity 36 kilometers per hour, find the tension in the string. Okay. Okay. We are given the resistance, total resistance proportional to mass. Okay. Total resistance proportional to mass. Okay, let's say we are given a word, no? The resistance against the motion is proportional to the mass. If I take resistance as R is now K times mass is 1750 total mass. R is therefore 1750 K. Okay. K is a constant, no? K is a constant. Okay. Now we are given there. System is moving with an acceleration 1 meters per second squared. The resistance against the motion proportional to the mass. And if the system moves with the velocity 36 kilometers per hour, right. We are given acceleration 1 ms minus 2. Velocity at this moment, velocity is 36, no? 36 km minus 1. How to convert kilometers per second to kilometers per hour to meters per second? Multiply by 5/18. Huh? This is 10. Then moves with 10 meters per second. Okay. Then we can write first one. The attractive force. The attractive force is, you know, H equals Fv, equals H upon V. F. H means 45 kilowatt, 45 into 10 to the power 3. At that moment, velocity is 10 meters per second. Then this gives us 4,500 newtons. Okay, now this way we have 750 G, 1000 G. Here tension T. Okay. Here, what is the result? Resistance here. Force mass is 750, no? 750 K. Here, what? 1000 K. 1000 K. Right. Now we apply. Right. Marks coming like this. For this 5 marks. Right. We apply F equals MA. We apply this way. What is the force? Effective force F. 4,500. For the system we apply, yeah? For the system. For the system means what? For the truck and the trailer both. Then T, they cancel off. They become internal force. Okay. Then tractive force is F 4,500. Here 1000 G sine theta, 750 G sine theta. 1750 G sine theta. And what? 1750 K resistance. That also minus. Equals mass 1750. Acceleration is 1. Then sine theta, put 1/10. Take G as G 10 sine theta 1/10. When you simplify this, you get an answer for K. K comes as 4/7. Here, marks come in. To the left hand side of this F equals MA, 5 marks given. To the right hand side, 5 marks. For the answer of K, another 5 marks. Now what is asking? Asking the tension in the spring. Now what we do, now we apply F equals ma for the trailer. At this moment, trailer moves with acceleration 1 meters per second square. Okay. Then we get for trailer F equals ma this direction t minus 750k 750 g sine theta. Mass is 750, acceleration is 1. Okay. For this we get 5 marks. Here also substitute for k 4 by 7 g10 sine theta 1 over 10. Then find t. T comes as an answer like this. 1500 into 9 divided by 7 newtons. Yes. For this you get 5 marks. Okay. Next on the vector question. Right. Vector question. Usual notation, the Poisson vectors of the points A and B related to O are I plus j. C be a point on the line which passes through A, right? Yes, passes through A, parallel to OB. Yes. Y-axis is, x-axis is vector I, y, j, here we have B, I plus j. OB. Point A is here. Poisson vector is I, no? I plus j Poisson vector means what? Point 1, 1. I Poisson vector means 1, 0. 1, 0, no? Yes. Okay, let's see a point on the line which passes through A parallel to OB. Parallel to OB, the line passes through A like this. Huh? Okay, on this line, there's a point C like this. Let's draw parallel. CB a point on the line passing parallel to OB. Show that OC is lambda real number. Find the value of lambda such that OB is perpendicular to BC. Yes, OB is perpendicular to BC, right? I can write OC here. OC. What is diagram 5 marks? Right, we can write OC vector as OA vector plus AC vector. OA vector simple I AC vector is parallel to OB. Therefore, AC vector I can write lambda times OB. Lambda times OB. Okay. Lambda is a real number. For this 5 marks. In OC vector we can write. Okay. I time plus lambda OB. I plus J. Then I can write OC. Take I vectors together. This way. Other 5 marks coming here. Right. Next one we can write BC vector. B to C vector I can write BC vector BO plus OC. BC vector BO plus OC. BO minus I plus J. OC vector is 1 plus lambda times I lambda J. Then BC vector we can write taking all I vectors together and J vectors separately together. This way lambda I plus lambda minus 1 J. That simple thing. Taking I vectors together and J vectors separate together. Okay. For these 5 marks. Right. Now we need to find lambda such that OB perpendicular to BC. All right. Here 90 now. OB perpendicular to BC means when two vectors are perpendicular, we know what dot product is 0. Right. Dot product of the vectors is 0. OB vector perpendicular to OC vector implies that OB vector dot OC vector is equal to 0 vector. OB vector I plus A. OC vector is sorry. I made a mistake there. OB vector, BC vector, no, perpendicular. ABC vector. Then dot product is 0. OB vector I plus J, BC vector is this lambda I lambda minus 1 J equals 0. Right. How to simplify here, people? For this, we get 5 marks. How to take the dot product between IJ vectors? I coefficients we multiply, J coefficients we multiply. Yes. I coefficient 1, 9 lambda lambda. J coefficients 1, 9 lambda minus 1. Right. Equal to 0 lambda half. For this other 5 marks. How many marks now? 5, 10, 15, 20, 25, 30. Other 5 marks you should get. Diagram 5, correct? Yes, 5, 10, 15, 20, 25, 30. BC. Another 5 marks coming for this. Taking this answer. Final answer 5 marks. 35 for that. Then for whole question 100. For whole question 100. Okay, next one. Relative acceleration. Relative acceleration question. Okay, the figure shows vertical cross-section of a smooth wedge to its center of gravity of mass capital M. The face AB is on a smooth horizontal plane. Two particles P and Q, each of mass M. Yeah. Place close to E and D. Okay. Write down sufficient equations to find acceleration of the wedge relative to Earth and acceleration of particles relative to wedge. Find the acceleration of wedge relative to Earth and depth of the particles relative to wedge. Okay, fine. This way we have the wedge this angle is 45. Yeah? 45. Length given as A. That's not anyway important to us to take down. So it's also A. This is beta. Here to A. Capital A. B. C. D. E. Here. Weight mg. Suppose normal reaction R. Right here. Weight mg. All the forces you must mark here. Normal reaction is weight mg. Right. I take the acceleration of wedge relative to Earth, capital F. This relative to wedge F2. Okay. This relative to wedge F1. And weight of the wedge capital Mg, normal reaction R dash. Okay. Right. When you draw this way, marking all the forces and acceleration, we get some marks for the diagram. Here we get 20 marks for the diagram. 20 marks for the diagram. This is the particle P. This is the particle Q. Then accelerations we can write relative to Earth. A of P relative to Earth. F1 this way. Capital F this way. With this angle beta. Q. F2 this way. Capital F this way. This is 45. Right. Acceleration of capital M, that means wedge relative to Earth, is this direction, capital F. Here for this, 5 marks. For this, 5 marks. Here we can draw right angle triangle. Here A, 2A, here root 5A. Then sine beta, we can write 2 over root 5 cos beta 1 over root 5. Right, no? Now we apply F equals MA. Number 1, for all system rightward. No external force, 0. Right hand side, product of mass and acceleration. Capital M, capital F. Here, P, simple M. Take acceleration here. Capital F minus F1 cos beta, no? F1 cos beta. Cos beta is this 1 over root 5. F1 cos beta means F1 over root 5. And P, Q, M. All right. Capital F. F2 cos 45. Cos 45 is 1 over root 2. F2 over root 2. Okay. Marks come in for this 5. For this 5. For this 5. By this, we can write one equation. Take in all capital F terms together and simple F1, F2 separated together. We get like this. When you take all capital F terms together, we get like this. MF2 over root 2 minus MF1 over root 5. Number 1. Second one, we take F equals MA for P this way. Mg sin beta force. Sin beta is 2 over root 5. 2 mg over root 5. Mg sin beta equals m times here. M times for the expression F1. This capital F use this side 5 marks, this side 5 marks. Okay. Then third one for Q. For Q, we apply F equals m this way. Mg sin 45. Sin 45 is 1 over root 2 equals m times that direction acceleration come in here. F2 plus F cos 45. F2 plus capital F cos 45. Cos 45 is 1 over root 2. This and this we can cancel down. We get G over root 2 is equal to F2 plus capital F over. Here. 5 marks. 5 marks. Okay. By number 2, subject F1, right? We get 2g over root 5, takes the side, capital F over root 5, no? Then we get 2g plus f over root 5. By number 3, subject F2. By number 3, subject F2. F2 what? There is a side, g minus capital F divided by root 2. This both F1 and F2, we substitute in number 1. Then we get capital F. Huh? Substituting in 1. In number 1. What do we get? 0 equals m plus 2m capital F m over root 2 F2 is answer. G minus capital F over root 2. Next one. Minus m over root 5 F1 is 2g plus F over root 5. Okay. For the substitution, we get 5 marks. Okay. Now simplify this. Correct, no? You can take this root 2 to root 5 root 5. Right. How to simplify this now? Yes. Take f out, m to m. Okay. Here we get minus plus minus root 2 to m by 2. If we take out m by 2. Here root 5 5 m by 5, f is outside, minus m by 5. Next one's here root 2 mg by 2. Here minus 2 mg by 5. Okay. Right, take this to this side and subject f. I'm not going to write those steps. F comes like this, minus mg divided by 10 capital M plus 13 simple M for this 10 marks. F is negative. It says what? The wedge moves to leftward. Okay. Yes, now F1 and F2, simple F1 and simple F2, you can take. Simple F1 is really this answer, no? 1 over root 5 2g. This root 5 I wrote as 1 over root 5 2g plus f. F is this answer. Minus mg over 10m plus 13m. Simplifying this, you get F1. This answer. Root 5 coming. 4 capital M plus simple M times G divided by 10m plus 13m. 5 marks. Okay. Here 5 marks. Substituting for these 5 marks. I am simplifying, taking this answer another 5 marks. F2 also we can take, right here, substitute for F. 1 over root 2 G minus F is answer. Then plus mg over 10 capital M plus 13M. Right. For these 5 marks, and answer of F2 come in this way. Root 2G over 10 capital M plus 13 simple M, 5 capital M plus 7M. You see, another 5 marks. Yes. Okay. Who got these answers? Hey. දැන් ඉතින් පුළුවන් වෙන්න ඕනේ answers ගන්න. ඒ කියන්නේ වැඩ කළා මදි. Right, no? Question number 4. Right, no? Right. Okay. Next from the circular motion question. In the circular motion, it contains collision also. Particle P mass M 22.0 by light invisible string of length 2a. Initially, the particle P is at a height at a point A, height 2a vertical above O. Another point C is on a smooth horizontal table at a depth 2a vertical below O. Particle P is given horizontal velocity root 24 GA from A. And while it is moving on a circular path, as it reaches the point C, it collides directly with a particle Q of mass 2m moving in opposite direction with velocity 2 root 2 GA. Right. It's a very good question. Who did this? කරන්න එපා. පාඩම් කරන්නේ නැහැ. තාම හිතන් ඉන්නේ එක්සෑම් සීන් ලැබුණ අවුරුද්දේ කියලා. ඔව්. Here we have 2a height, point A. We have there particle P is mass M, particle P placed, given a velocity root 24 GA. See, it moves. Right. Let's ask him first. Show that the velocity of P soon after impact is this answer. All right. Okay. Once this P, this particle P, coming along the circular path to this position, I'll take its velocity as u. P come in here with velocity u. U. At the same moment only, q, okay, moves this direction, root to g a. This lowest position point is C. P is Q. Right. Particle P of mass Mn Q 2m, no? Yes. This is M, this is 2m. Okay, first we'll find this U. We apply conservation of mechanical energy, taking this level as potential energy 0 level. Conservation of mechanical energy we apply. Here, total energy, no potential energy, only kinetic energy, half mu squared. Half mu squared equals, over there, half m velocity squared means 24 GA, and potential energy mgh. mg height means 4a. Right. Then marks come in here. 5 marks for this. 5 marks for this. 5 marks for this. M you can cancel down. Right. Multiply by 2. Here 24 GA, 8 GA, 32 GA root. U comes as 4 root 2 GA. For this 5 marks. Right now, collision takes place. collision takes place. Huh? Just before the collision, velocity u and this u velocity we know. Okay. Then I can do that here. 2m q moves this way, given velocity 2 times rho 2 ga p with mass m comes this way with this velocity for root 2 ga. After impact, I'll take q moves this way with velocity v2, p moves with velocity v1. Right. Right. Now, for this impact, we can apply conservation of linear momentum and Newton's law of restitution. Right. Yes. Here, momentum to CLM. We apply CLM rightward. 2 mv2 plus mv1 is equal to 2m into this, 2m into this. This is minus m into 4 times this 2ga. Right? People, you know, is 2 equal, no? We can cancel it out. Right. Yes, for this we get 5 marks for this equation, 5 marks. And taking that equation simplifying, what do you get there? If we can cancel down, no? This right hand side 0 now. It is v1 plus 2v2. v1 plus 2v2 is equal to 0. This is number 1. 5 marks. NLR, Newton's law of restitution, we apply. What's that? Velocity of separation, v1 minus v2 equals E times velocity of approach. 6, no? 6 times root 2 ga. 6 times root 2 ga. It's number 2. Okay. Here to the left hand side, here 5 marks. Right hand side, 5 marks. Okay. Then we can find v1. What is asked in there? Show that the velocity of p soon after impact, velocity of p soon after impact is v1. We need to find v1. Yes, v1 we can write 1 is added to second one, multiply second one by 2. 2 is v1, v1, 3, v1 now, no? Because this multiplied by 2, no? And here we get this way 12 e root 2g a. This and this you can cancel out. View 4 e is root 2g a. 5 marks. Okay. Okay, what's the next part? After certain time of impact, the string OP makes an angle theta with OA. Find the tension in the string at this moment. Find the minimum value of E so that the particle P performs complete circular motion about O. Hmm? Yes, here. Soon after impact, particle P now moves this direction with this velocity OE to GA. Right, this is the point O. Hmm? It now moves like this. Huh? It comes to a position like this. mg tension T. Let us take the velocity here as V. K9. Hmm? We'll take the potential energy 0 level here. Hmm. Right. So then this angle given as theta. Here 2A, this is 2A. We'll find the V because we need this velocity V to apply F equals ma towards center to find the tension T. Right. So then conservation of mechanical energy we apply again. Here total energy only kinetic energy half m square of this one. 4E root 2GA perfect squared equals here half m V squared plus this height. This is 2A in 2A cos theta plus 2A mgh 2A plus 2A cos theta. Here 5 marks. Here 5 marks. Here 5 marks. Okay. Simplifying this, we get V squared. I'm not going to show the steps in taking this V squared. You can do that. Huh? Just cancel down this m, multiply by 2, and anyway simplify this. We get this answer for GA 8t squared minus cos theta minus 1. Right. For this 5 marks. Now we apply F equals ma towards the center. T, this is theta. T plus mg cos theta is equal to mv squared over 2a. Here 5 marks. Here 5 marks. Then subject T m over 2a. Substitute for this v squared. This answer for GA 8e squared minus cos theta minus 1. And bring this mg cos theta to right hand side. Minus mg cos theta. Here, this and this and this, you can cancel down. Anyway, simplify this, mg, you can take out. Then T, we get mg times 16e squared, 16e squared minus 3 cos theta minus 2. We get 5 marks for this. 5 marks for this. And substituting here for this v squared, 5 marks v mark. No. Yes. What are the condition required for the complete circles? We know for the complete circle, at the highest point, t should be either positive or 0. That means highest point means when theta 0. Right. Can write for complete circles, about tau t at the highest point. Highest point means theta 0, greater than or equal to 0. This is 5 marks. Right. Put theta 0 here. mg 16 e squared. Theta 0 means people here. Cos 0 1 no, minus 5, greater than or equal to 0. mg not 0 no, then 16 e squared minus 5 greater than or equal to 0. E greater than or equal to root 5 over 4. What's E minimum? E minimum is therefore root 5 over 4. Okay. Yes. So here, simplification 5 marks. And for the last answer, 5 marks. Okay, number 5 next. Question number 5 next. Question of I think we did in the class also. Yes, did that one. Yes, question number 5 we did in the class. Right. Right. Now, yes, for uniform plots this way. Yes. First of the light rod is 2W root 3 we have shown. Reactions on the pegs on rods BC and CD. With the midpoints BC and CD touching on 2 pegs. Yes. Here must be a B, B. This is C. A. Right. This is 2A. Length. Uniform roads. Weight W at midpoint of each road. W. Here also acts at the midpoint. Weight. Here. Right, like so. Interior angle 60. A, 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 A. System is symmetric, and here the pig has been placed. All right. By the pigs, now reactions come in. They are equal because system is symmetric. System is symmetric. Due to symmetric. Due to symmetric reactions at A and C are horizontal. No vertical components. I take this as X. This as X. And this also therefore X. Due to symmetric reactions at A and C are horizontal. Here I take X1. The directions of the reactions we mark may be opposite. Never mind. If so, in the final answer, you get for them negative. It's angle 60. This is 60. Here 60. This is also 60. Right. Okay. For the diagram, with all forces marked correctly, in this question, 25 marks coming. Since you get 25 marks here, because all 100 marks should be shared. Okay, so then you must first write this thing. Due to symmetry, reactions by the pigs are equal. Due to symmetry, reactions by the pigs are equal, and the reactions at A and C are horizontal, and the reactions at A and C are horizontal. For that statement, 10 marks. Hmm? 10 marks. Yes. Now, the whole system we resolve upwards. Yes. Right on. For the system, we resolve upwards. Here, when I draw vertical line, here, vertical line, here 60, 30, this is 60, this is 60, R cos 60, R cos 60, 2 R cos 60 upwards, downwards 4W, 2 R cos 60, downward 4W. Cos 60 half, this and this we can cancel down, R equals 4W. Here, 5 marks, answer 5 marks. Yes, next one. For the road BA, we take moment around B. Oh, the road BA, take moments around B. Yes, what do you get? X gives anti-clockwise, W gives clockwise moment. This is 60. This is also 60. X into 2A sine 60. W into A cos 60, no? A cos 60, correct, no? When you produce this way. Right. A, we can cancel down. X, sine 60, root 3 by 2. 2 and these 2 we can cancel down. Root 3x, cos 60 is half W by 2. X equals W over 2 root 3. Here 5 marks. Here 5 marks. Answer 5 marks. Right, next one. For the road BC, we take moment around B. For the road BC, we take moment around B. Right. We write that here. For BC, we take moment around B. We take anticlockwise. What are the forces? R around B gives anticlockwise, X anticlockwise, W clockwise. Right. R already perpendicular to this point. R into A plus X1, the perpendicular distance here. We can drop perpendicular here, right? If this is 60, no, 2A sine 60. 2A sine 60. W gives this a clockwise moment. Here 60, this is 60, then A cos 60. A you can cancel now. Okay. R for W. Here sine 6 root 3 by 2, that 2 and this 2 you can cancel down. Root 3 x1 cos 60 half W by 2. Okay, here x1, when you subject, we get minus 7W over 2 root 3. And here we get 5 marks. For this we get 5 marks. For this we get 5 marks. Here 5 marks. X1 negative, it means the sense should be opposite. Don't go to change that now, even though we get minus sign here. Right. Next one. Let's ask him next. Yes. For ABC part, resolving forces. This ABC part. ABC part, we take forces resolving horizontal. Right. Now we can write it here. For ABC part. Resolving rightward. What do you get? R. R sine 60. No, towards the angle cos, away the angle sine. R sine 60 rightward. R sine 60 plus x1 plus x1 also rightward. T and next leftward. T plus x. Right. R 4W sine 60 root 3 by 2. X1 minus 7W over 2 root 3. Bring this x to left hand side, minus x. Its answer is W over 2 root 3 equals T. Yes, for this 10 marks coming. And once you simplify this, you get the answer for T 2W over root 3. For that, other 10 marks. Last question, boss notation part. Okay. Boss notation. Who did boss notation? No. Framework shown in the figure consists of 5 light rods this way, smoothly jointed at the ends. It is given that ABBC equal, ADBDC equal, and so on. Now, yes. It's really hinged at A, and the load 3W is suspended at the joint C. The framework is kept in equilibrium in a vertical plane with AD vertical and AB horizontal by a force R at the joint D in the direction shown in the figure. Draw a stress diagram using Bose notation, hence find the magnitude of R. That means we must find the R by using stress diagram. If you take moment and any other way, no marks. Yes. And reaction in J, also find the stresses in the 5 rods, stating whether they are tensions or flux. Right. Okay. Right. Regular diagram, yeah. Okay. Here A, B, C, this is D. Here force R given. Wait, yes. To represent the reaction at A, we draw a line like this. Yes. We are given AB, BC equal. These two are equal, right? And also ADD is equal. ADD is equal, right? And ADB, BDC 30. ADB, BDC 30. 30 here, 30 here. You can very clearly see these two triangles are congruent, no? So reason, this side, this side, this side, this side, this side common triangles are congruent triangles. Therefore, this should also be 90. Here, because this is 90, AB horizontal, AD vertical, we are given in the question. That's right. And then, wait, 3W suspended here. Okay. This is region A, region B, region C, region D, region E. Right, this is 60. 60 here also 60. Right. Right, now we'll draw. First, we can come to the joint C, A, B, 3W, B, C. Yes. You can very clearly see this is 60. Then this also 60. When I produce this line this way, okay, this is 60. Here 91, 50. Therefore, this is 30. Okay. BC makes with vertical 30. Right. CA vertical 60. Right. Okay. Then we draw AB. AB downward 3W. Downward 3W. BE. B here with vertical 30. Parallel to BC road, draw a line through the point B. You say making 30 with the vertical like this. So okay. On the line this, we should have the point E. Right. EA should be parallel to this CD. That means EA means through the point A, we must draw a line parallel to CD. That means making 60 with the vertical like this. Making 60 with the vertical like this. Huh? Okay, this is 60. Then this point should be 8. Here, therefore, this is 90 because we do this as 30 with the vertical. Here, 90. Right. Okay. Now, secondly, here, joint D you can't choose because we know this CD road, the stress, but 1, 2, 3. 3 unknown forces. Yeah, D at D available. We always select what? A joint having 2 unknown forces. Right. We found this BE. BE can be found, no? Then at the joint B, two forces. Right, unknown forces, right? What is this? BD horizontal. BD horizontal like this, no? BD horizontal. Somewhere on this line, D should be right. BD horizontal. DE. DE. D should be on this. DE must make. This should also be 30, no? DE means this BD. Right. DE line should be drawn parallel to BD rod. BD rod makes 60 with the horizontal. DE line should be drawn parallel to this BD. D should be somewhere on this. E is here. Then we have to draw a line to this E parallel to this BD rod, making 60 with the horizontal like this. Okay, 60 with the horizontal. This is 60. This point should be B. Okay. Speed. Right. Okay. Then that joint also okay. Now we can come to the joint D. Reason? Now this rod we know, this rod we know. Then at joint D, there are two forces unknown. This and this. DC vertical, CA horizontal. DC vertical to the point D from a vertical line like this. Somewhere on this line, point C should lie. CA horizontal. Draw through the point A horizontal line like this. They meet somewhere. This point D. Yes. This is the stress diagram. Now, this force given by BC, then we'll join B and C. Right. Here 60, all angle 60. This is 60. Yeah, for this also 60. Okay. Now we can go to calculation part. For this stress diagram, 30 marks given. This is 90. Right. Okay, now we can do the calculation. AE, this AE, what is that? This is 3W, this is 60, 3W cos 60, 3W by 2. Cos 60 is half, no? एमने आई कल्पना करा 3W by 2. Okay, and BE, you know, this triangle BED, BED triangle, equilateral, equilateral. All three sides are equal. BE equals DE, right? Equals BD. These three are equal. This three are equal. Equal to BE length. What is BE length? 3W. What? Cos 30. Here 90, no. 3W cos 30. 3W cos 30 means root 3 by 2. Right. That means 3 root 3 W by 2. BE, DE, BD. Right. BE, BD, DE. DC we have to find. What is this? I have made a mistake, no? DC vertical. This should be C. DC vertical. CA horizontal. This is C, yeah, not D. Right. You know, this is a what? This is a rectangle. BD and AC equal. AC is equal to BD. BD means 3 root 3 W by 2 AC. Right. DC or CD. CD equals to 3W. Right. Correct, no? All we found. 1, 2, 3, 4, 5. Yes. Okay. Now the reaction here at A given by this BC. This is 3W we found. BD we found. 3 root 3W by 2. Then BC squared. BC squared we can write how? BD squared plus CD squared. BC squared. BD is 3 root 3 W by 2 perfect squared. CD squared 3W perfect squared. Okay. 3W perfect squared. 3W perfect squared I can take out. 3W perfect square I can take out. 3W perfect square when you take out here we get root 3 squared 3 by 4. Here 1. This is BC square. BC is now 3W square root of here we get 7 over 4. Right. Okay. Okay. Then we get BC 3W 3 root 7. 3 root 7 W by 2. Yes. For this all calculation, 20 marks given. And here for this 5 marks, taking this answer 5 marks. Okay, not only that, here the direction also you must take. Let this angle be alpha. What is that? The reaction at A makes with the horizontal alpha. That also you must find because it's a force. What is tan alpha? Tan alpha is what? Here, this is alpha. CD divided by BD. CD divided by BD. CD divided by BD. Yes, CD is what? 3W. BD 3 root 3 W by 2. Right. Then tan alpha. equals 2 over root 3. Alpha tan inverse 2 over root 3. Okay. For these 5 marks. Okay. Then you must write final answers for R and this reaction. Okay. Then you can write therefore R 3 root 3 W by 2. For this, you get another 5 marks. Remember, because there we found that CA, but we must identify by CA, we get the force R. That you must write here. Because asking this R, reaction at A. Reaction at A. All right. So it is this direction. Why do we take this direction? Reason, here, when you turn around A, BC, BC, okay? BC moves this way. That's why we put the arrow that way. This is alpha. Right. It is 3 root 7 W by 2 alpha tan inverse 2 over root 3. Now, you must write this on the 5 marks coming. Right. Now, the table. Now, the table. Make the table. Here, rod. Press, tension and thrust. Here, we'll mark the tension and thrust. When you go to joint D, rotate anticlockwise, AE. AE this way, right? This rod stress is given by AE, the rotation this way, AE. AE. Look at there, AE this way. Then must have like this. That is a thrust. ED, 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 yeah, ED this way. This was given by ED, no? That was it this way. All right, this way. Other end this. DC, DC up here, here. BE, BE this way. Other end this. BD this way. Right now. That's all. Fill the table. You know everything. Okay. Now we can fill the table. Everything available there. Fill the table. The table, 25 marks. If you miss or go wrong one answer, 5 marks deducted for any wrong answer. Okay. Here. Right. We can complete this. This is the end of the discussion of paper number 9. is the end of the discussion of step number 9. Yes. Okay, no? Yeah. Okay, we will stop here. Tomorrow we have the